Greg. Thanks for joining us today. I wanted to talk to you a little bit about some of the unique challenges that face water treatment plants and the different technologies that they employ from a cybersecurity perspective. First, I just wanted to ask you, can you describe some of the unique cybersecurity challenges faced by water treatment plants, especially as it relates to their industrial control systems and their operational technology?
Yeah, there's a few different things that places like that. So the ICS and OT, industrial control systems, operational technology, the threats that they face and how they have to defend those threats are different than most standard businesses. Do they have a business network? The ransomware is still a threat to them. Data exfiltration is still a threat to them. Denial of service is still a threat to them. The problem that they also have to deal with is they also have to deal with life safety issues, right? So things that industrial control systems and operational technology touch are usually things in the real world, right? So they're used to control electrical grids, used to control pumps, used to control mixing stations, and those sorts of things, process, right? And those processes have connections to the real world with real world consequences. So now you're not only dealing with traditional cyber threats, you're dealing with people who want to cause damage, right? So you're dealing with a different level of actor, right? So you have your traditional cyber crime actors, and you have these kind of nation state type actors, right? Whose goal it is to create chaos or create damage or hurt people and those sorts of things. That's a different type of threat and a different skill set on the adversary side, right? So those are more difficult attacks to defend against just on a whole. Now you add in the design of what a control system is and how it sits, right? So control systems operate in the real time, right? For the most part. You're controlling a motor, you're controlling a pump, you're controlling electrical grids. Those things happen in real time. So the protocols that are used in those systems, the way those systems are designed, they don't have security built in. Like, it's not like you can have an encrypted link between your SCADA system and the breakers and things that it's controlling, because that stuff happens in real time, and it has to happen in real time. Encryption takes time, right? So the protocols aren't designed to be secure. They're designed to work fast. They're not designed for what's called confidentiality, right? Because the data that runs in industrial control systems is not really good a few milliseconds later, right? It's good for right now. So to defend those systems, you have to think about it a little differently. You have to instrument and look for things a little bit different than what you're going to look for in a normal environment, right? So you have to put networking monitoring and all those other things in place to watch, but you have to be very, very careful. If you're trying to look for vulnerabilities in an industrial control system and you fire off like a Nessa scan or something like that, you're probably going to bring that control system down, right? It's not designed to do those sorts of things. So it just takes a different methodology, a different thinking towards defending those type of operations. They are very, very vulnerable, right? So the problem that we've had in that type of sector is, it used to be just, hey, let's just air gap that stuff off, right? So let's disconnect it from the internet and just not have it connected, and we'll maintain it internally and those sorts of things, that's a good approach. I mean, it's not foolproof, but it's definitely a much harder target when you do those sorts of things. The problem comes in is those systems today need to be connected to the internet. We have less operators, right? So people are doing things remotely. So they're trying to run those systems and maintain those systems not being on site. They have regulatory obligations like to the EPA and things like that, where they have to report in data at a certain time. They get fined if they don't. So they have to have those things connected at all times to get that kind of business data out to keep the operation running. So that facilitates connecting these things in some way, in some fashion, to the internet. And if there's one connection, that's all an adversary really needs. So this is why, in the ramifications from a successful attack, again, life safety, much, much worse than a ransomware attack. Again, I'm not going to belittle the fact that someone gets ransomware and their business has to close, but people can die from a successful cyber attack against a water plant or any other industrial control system type facility.
So industrial control systems, it sounds like these water treatment plants and other types of components in our critical infrastructure, they need these operational control technologies. They need the industrial control systems in order to function the plant. But it sounds like that puts them at a significant risk compared to maybe your normal law office or accounting office or doctor's office, right? There's something about these ICS and OT systems, or many things about them, that really make these plants extremely vulnerable, more so than your average SMB. Is that right?
Well, just look at what the outcome would be, right? So if you take the successful outcome of an attack, let's just take a water treatment plant. Let's say I'll just use my town for example, right? So I live in a small town, about 5,000 people here. We have a water treatment facility. If that water treatment facility is put offline for any point in time, right? Or you're able to contaminate that system for a period of time where, again, people don't have water. That's a big deal. You know, that's 5,000 people that, you know, I'm on a Barrier Island that don't have water, that need to go somewhere else, right? So that's a huge impact versus, again, I'm not downplaying the severity of it, but if your law office goes offline for a day or a week, yeah, you're going to feel that, but the impact of the greater public is not affected by that. You know, again, you can, if you blow up a water treatment plant, God forbid, right? So the water treatment plant they have things that are dangerous, like and hydrogenous ammonia, right? They use in part of their process. Very dangerous chemicals, right? So if you're able to spew that kind of stuff in the air, right, now you're poisoning people. Again, the outcome could be death in the end, right? So it's that life safety thing that you just don't have that kind of risk in a law office, right? So if I blow your server up, it's not, you know, it's not physically blowing up. It's encrypted or it's deleted or whatever the case may be. In the real world, you cause real physical damage, which could cause real physical harm to people. So that's a whole different stake when it comes to the outcome of a cyber attack that makes defending those type of operations, ICS and OT operations, extremely important, right? But there's not a whole lot of subject matter experts. There are some. There are people out there. Obviously, there's people like us that have subject matter expertise around industrial control systems. But it's not the normal security companies that have that, right?
You know, you mentioned some of the specialties that we have internally that allow us to protect these types of facilities. Can you speak a little bit about what is it about our fully managed XDR suite and our SOAR functionality and some of our other technologies that allow us to be uniquely able to help water treatment plants with their cybersecurity?
Yeah, so I'll talk about my personal experience, and unfortunately I can't give out like the details of some of our analysts, but we do have analysts that are subject matter experts on ICS and OT. Myself personally, I spent probably 7 years in a plant doing security in IT operations, and so I have training on a vast variety of industrial controls, real-time industrial control systems, X-ray gauges, you know, PLCs and all kinds of stuff. And so I was fortunate enough when I started my cyber career to already have a background in hands-on experience with industrial control systems. And so I was also contracted by NASA to defend both offense and defense against industrial control systems, right? So the way you really get good at something is to teach it, right? So, and teaching to those guys, these are launch control engineers, SOC engineers, and things like that, you know, and listening to their challenges in defending these systems, you know, positions us with that. And then again, we were lucky enough to hire a couple engineers and analysts that have a background in that industrial control system, so who are actually, you know, subject matter experts for specific organizations on industrial control systems. So it does allow us to instrument networks properly and understand what to look for, right? So, you know, our system is a combination of both network data, right, which is really what you need to be able to defend an industrial control system. You really can't be injecting things in or trying to put agents on things and that sort of thing. But ours is a combination of looking and properly instrumenting, and there are ways, you know, the government has, you know, procedures with the risk management framework with NIST and other things around the cybersecurity framework that was designed for industrial control systems of how to properly instrument those networks, and our system does that by default. Like if we put our system in, we're going to instrument that network properly and look for the right protocols, right, and look for how that thing is working. And then when you jump over to the business side of because there's always a business side to the ICS and OT operations, right? They have a business network. It's where what's called their historians sit. So there's some linkage between their control system environment and that business network. Properly putting in, you know, monitoring agents to look for things there as well, right? So now we can monitor the traditional IT business part of what they do, and we can tie in the industrial control system piece. So now we have a holistic view of that operation, right? We're not separating them out. We're looking for things that could come in on the business network and how those things would traverse onto if possible, traverse onto that control system network, which should be protected. So, you know, anything that happens in the environment we can see, and including mistakes, right? So that's usually how things happen, right? So you go into a place and they have really good controls between their control system network and their business networks, and then all of a sudden something changes and no one notices, and that's when an adversary will take a foothold to get in that control system network. So we can monitor those things, and we start to see odd protocols in the business network that don't belong there, odd traffic patterns between the business network and the control network, or control networks, those sorts of things. We can monitor for those things and respond to those anomalies to make sure that an adversary isn't getting a foothold in there to do more nefarious things.
Mm-hmm. Yeah, I know that's one of the aspects of our solution that I know we get a lot of great feedback from our partners on, is our ability to provide like a holistic view of their IT infrastructure, right? So if we see it, like you're saying, if we see a threat over here, we see a threat over here, we can correlate those threats and, do some more research on what's exactly happening. Whereas other solutions, maybe they're protecting one part of your network, or they're not, or your infrastructure, but they're not protecting or even communicating with the other aspects. So you're not able to get really a holistic view with some of these other solutions that are on the market.
Yeah, and what you have to be wary of is, there's, especially again, so you're when we're talking about water treatment plants and industrial control systems in general, realize that you could be dealing with a next level adversary. And what I mean by that is a talent, someone who's really good at their job, right? So from the adversary perspective, so someone who's very serious about doing damage. They're not just going to come in and start, right out going for what they want to go for, right? They can put up smoke screens. They can be doing other things to try to distract you from what they're actually going to do on the other end. So if you're not looking holistically at everything, you may be getting something that they know, like they may be attacking parts of your business network or your cloud or things like that to draw your attention over there while they're trying to do something here more low level on an industrial control system where you may not be looking as hard, or you may not have the technology to instrument that properly. So they can draw your attention away. And again, this was done in that power grid attack in several different ways. So it's a tactic that's used. So by not looking holistically at those things, you're going to miss, right? So we don't want to have a miss, and that's why when I say that, you need to instrument your facility properly. That's a really true sense of that word. Is you need to have the monitoring points at all the places that you transition between networks and systems and those sorts of things to watch, and that gets very, very important on the defensive side.
I'm wondering if you're able to, you may not be able to, but I'm wondering if you're able to share a story or two about like an attack that we identified in either a water treatment plant or just an industrial control or operational control system, something that our technology allowed us to detect that maybe another solution would not have picked up, or maybe they even missed, and how we were able to recognize
that. I can give you one. I obviously can't say who it was. I can say it was a water treatment plant, particularly. This water treatment plant was breached, so we were brought in post exploitation. So it means that the adversary had access to some things, but what would happen is they would turn on what's called an HMI. An HMI is called a human machine interface. It's a fancy word for a computer that you utilize to monitor the process in a plant, so in a water treatment plant. So you're monitoring pumps, you're monitoring how much anhydrous ammonia goes in your process, all that kind of stuff, right? You're doing. And the HMI can set points into what that has to be. So the operator can look and say, okay, well, I'm not getting the right output. I need to adjust things. And that's what they do from their HMI, so the human machine interface. They would turn on this HMI, and within a few minutes, someone had hands-on access. The mouse would move, they were trying to do things on there. And that's a big deal. Like, so now all of a sudden we have an adversary that has hands-on access inside your control system network. That's a big deal. That's going to throw up red flags and everything. People start pulling cables and panicking and all that kind of stuff. So they were trying to figure out how that adversary had access. So we shipped them one of our sensors, and our sensors are, it's our platform, but we have incident response sensors that will go on the network and instantly start collecting network data right off the bat. Within 15 minutes, we noticed there was a piece of equipment, we didn't know what it was at the time, that was beaconing out to something on one of our threat intelligence feeds. So we watch, and we have this huge database of threat intelligence, compromised infrastructure that's all over the internet. It's kept up to date. There's a ton of information, and there's probably 500 million plus indicators in there at any one time. And they're updated hourly all the time. So we're just trying to track this known compromised infrastructure and look for anomalies around that. So we will track any connections from inside the network that tries to initiate a connection outbound to that, right? So, because that's something that probably should not happen. If you have an externally facing service, we're going to see those things hit from the outside coming in because we know they're compromised. But something inside talking out is not normal. So we noticed a piece of equipment that was talking out. And we figured out, well, okay, let's figure out what piece of equipment this is. It didn't have an EDR agent on it, so this is a piece of equipment that was on the network, did not have any kind of agent protections on it. So we started doing reconnaissance on that device to see what it was, and it happened to be what's called a Hikvision DVR camera server, right? That they forgot was on their network. They just didn't know. That device is a horribly vulnerable device that cannot be patched. So they have vulnerabilities in the firmware that cannot be patched. They need to be thrown away. So that device was actively compromised. So we try to log into, you can tell there's certain indicators of compromise you can look up around those boxes. And we can tell that box was compromised. So they were utilizing a connection to that box, and who knows how long they had it. And they had some stolen credentials. Now, we don't know where they got their credentials from, but they had legitimate credentials onto that HMI, and they were using that box to pivot and use a remote access piece of software, a legitimate remote access piece of software, to then control that box, right? So that by using that legitimate software, it got past all those EDRs, right? So even though they may have an EDR program or antivirus program with some kind of endpoint protection on that HMI, the program they were using to access it was allowed. So it was they weren't using a malicious piece of malware. They're using a compromised device that was off the radar of most normal tools to then take stolen credentials and log in that device and control it. So that didn't take us very long to figure that out, right? But that's, if you don't know that piece of equipment's there and you're not looking for that kind of stuff, it can drive you batty trying to figure out how that's happening, right? So getting that visibility in the network quickly, tells a story immediately, right? So you can start looking. That network data doesn't lie, right? There's nothing that the network is always a single source of truth. So when you're looking at data on the network, it doesn't lie. It's there, and that's how in that first level triage we can find out very, very quickly. This is how they're getting in, and you need to get this thing out of here immediately. Well, we didn't even know that was there. We kind of forgot about it. That happens. That that's part of the issue is water treatment plants, and they're probably not staffed by IT experts, right? They're operators there. They have budget constraints like everybody else. They may be using a county IT department that has 50 other plants under it, and all the other stuff that's involved with that. So the IT operations that go into there is not they don't have a huge amount of IT expertise that they go in those places, and this leaves them vulnerable to attacks like that.
That sort of reminds me of the stat that one of, if not the leading cause of a cyber attack is human error, right?
All the time.
So could you talk just a little bit about how does our solution, Blue Shift's XDR suite, how does it help protect organizations, even like one you're talking about, how does it protect organizations, or how does it sort of help eliminate, if you will, maybe that risk that is associated with human error?
So there's a lot of things we look at when you collect the amount of data that we do. You can look for anomalies, right? So you can take things that I'm going to back up 1 second. So there is an advantage to working in a control system environment when it comes to the data you can collect on those specific environments themselves. Control systems are what we call very deterministic. So the network traffic, the traffic that they're sending and what they're doing is a very deterministic thing. It usually does not change, right? So what I mean by that, they're not going out to the internet, they're not surfing sites and doing all kinds of stuff that you don't know. Those control systems talk to a very specific protocol, to a very specific machine, usually at the same volumes and those sorts of things. So the environment can be baselined in that control system environment. It can be baselined pretty easily. Versus when you have to deal with business networks, they're undeterministic, right? Mm-hmm. So you don't know, I don't know what Rob's going to do tomorrow when he gets on his computer. I don't know where you're going to go, what he's going to do, or who's going to download what, and all that kind of stuff. But there are certain data points you can take inside those business networks to normalize on. You can look at alert levels. You can look at other things to try to get a normalization on, and then look at the types of things you're seeing on that network and run a calculation based on the risk of what you're seeing there, right? So you can take, I'm seeing, these type of alerts or these type of attacks or these type of things we're seeing inside the network. We weight them in different ways based on the severity of what we're seeing, and then we can come out with this risk score is what we use based on our algorithm. And that risk score should stay pretty much constant, even in a business network, right? So even if you're going to different places, the risk profile that we develop on that network traffic should stay relatively constant. If it doesn't, that means that something has changed inside the network. It doesn't mean that it's changed it's a bad change. Could be maybe you added some more servers. Maybe you moved some stuff. Maybe you closed off something and the risk went down. But that change is something we can look at, right? So we can alert on the risk profile of this network has changed. Let's see what made that change. And is it something that could be a mistake? And we've detected mistakes like that before. People, right? So people are trying to do things, they're trying to multitask, they're trying to do a lot of different things. And when people are rushed, that leads to mistakes, right? So things like, changing troubleshooting something and changing a firewall rule, like putting it with the dreaded what's called the any rule in a firewall, like worst rule ever, because it just allows anything back and forth, right? So those sorts of things will show up in our system immediately, like because it's gonna cause the risk profile to change, and you need to be aware of those sorts of things. We've caught several of those, like that specific thing where someone has been trying to troubleshoot something with a vendor, it's not working. They say, "Oh, your firewall's blocking it." The IT guy says, "I don't think we are. I can prove that to you. Let me put this rule in. Allow any." No, it's still not working. So they keep troubleshooting, but they forgot they put that rule in there, and a couple of days go by, and then all of a sudden we're like, "Hey, our risk profile has changed. What did you do to this machine?" He's like, "I forgot I put that rule in there." Yeah, so don't put those rules in, right? So, but I get it, because because they're pressed for time, right? They're trying to eliminate as much things as possible, but by doing that, they end up making a mistake, and an adversary will absolutely take advantage of that mistake when they detect it. So we want to try to minimize. So I think mistakes are probably the third leading cause, and don't quote me on that, but I'm pretty sure it's probably the third or fourth leading cause of a data breach is a mistake that happens. And again, we call those the accidental insiders, right? So that is a threat model. When you talk about industrial control systems, you have insider threats, you have accidental insiders, people who may do something malicious and not. Again, that's not a malicious thing, but they can cause something malicious to happen because they've made a mistake. So.